Parallel universes, the mind-bending implications of the many worlds interpretation. Hey there, cosmic explorers and science enthusiasts. Welcome to another mind-blowing episode of Sci Discovery Chronicles. I'm your host, and today, we're diving headfirst into one of the most intriguing and controversial concepts in modern physics: parallel universes and the many worlds interpretation. Buckle up, because we're about to challenge everything you think you know about reality. Introduction. Imagine for a moment, what if every decision you've ever made, every crossroads in your life, didn't just lead to one outcome, but created entire realities, complete universes where each This isn't science fiction, folks. This is the core of the many worlds interpretation, an idea that challenges our understanding of reality and invites us to question everything we thought we knew about the universe. The quantum conundrum. To understand the many worlds interpretation, we need to start with the weird and wonderful world of quantum mechanics. Quantum mechanics is the physics of the very, very small, dealing with the behavior of matter and energy at the molecular, atomic, and even smaller microscopic levels. In the quantum world, things can be in multiple states at once. This is called superposition. Imagine a coin that's both heads and tails at the same time until you look at it. Strange, right? But this is exactly what happens in the quantum realm. The birth of a revolutionary idea, the many worlds interpretation, was born from the brilliant mind of physicist Hugh Everett III in 1957. At the time, the prevailing Copenhagen interpretation suggested that a quantum system remains in superposition until it is measured, at which point it randomly collapses into one of its possible states. Everett wasn't satisfied with this explanation. He proposed a radical alternative. What if, instead of collapsing into a single outcome, all quantum possibilities were realized, each in its own universe? In other words, every time a quantum event occurs, the universe splits into multiple copies, one for each possible outcome. This idea wasn't well received initially, but over the decades, it gained traction and became one of the most discussed interpretations of quantum mechanics. Understanding the many worlds. To grasp the many worlds interpretation, let's look at the famous thought experiment known as Schrödinger's cat. Imagine a cat in a sealed box with a flask of poison and a radioactive source. If the radioactive source decays, it triggers a mechanism that releases the poison, killing the cat. According to quantum mechanics, until we open the box and observe the cat, it exists in a superposition of states, both alive and dead. The Copenhagen interpretation suggests that opening the box causes this superposition to collapse into a single state. The cat is either alive or dead. But Everett proposed something different. When we open the box, the universe splits. In one universe, we find the cat alive, in another, the cat is dead. Both outcomes are equally real, just in different parallel universes. Mind-bending implications. Now that we've wrapped our heads around the basic idea as much as anyone can, anyway, let's explore some of the mind-bending implications of the many worlds interpretation. 1. Infinite versions of you. If the many worlds interpretation is correct, there are infinite versions of you, living slightly or radically different lives based on every choice you've ever made. 2. No what-ifs. Every possibility, no matter how unlikely, is realized in some universe. There are no roads not taken, only roads that lead to other universes. 3. Quantum immortality. Some theorists suggest that the many worlds interpretation implies a form of immortality. In any life-threatening situation, there will always be at least one universe where you survive. 4. Ethical questions. If every action creates new universes, does this change our understanding of moral responsibility? Do our choices matter less because all possibilities are realized somewhere? Or do they matter more because each choice creates entire universes? 5. The quantum multiverse. The many worlds interpretation suggests that our universe is just one leaf on an infinite tree of realities, each as real and valid as our own. 6. Quantum computing. Some researchers argue that quantum computers are actually performing calculations in parallel universes, potentially explaining their incredible speed for certain problems. Challenges and criticisms. As mind-blowing as the many worlds interpretation is, it's not without its challenges and criticisms. Let's take a look at some of the main objections. 1. Lack of observable evidence. By definition, other universes are beyond our ability to directly observe. This makes the theory incredibly difficult, if not impossible, to test experimentally. 2. The probability problem. If all outcomes occur in different universes, why do we observe some outcomes more frequently than others? The many worlds interpretation struggles to explain this. 3. Occam's razor. This principle states that the simplest explanation is usually the correct one. Critics argue that the proliferation of universes violates this principle. 4. The problem of identity. If there are infinite versions of you, what does that mean for personal identity? Which one is the real you? 5. Energy conservation. Where does the energy come from to create all these new universes? Doesn't this violate the law of conservation of energy? 6. Philosophical objections. Some argue that the many worlds interpretation is more philosophy than science, raising unanswered questions about the nature of reality, consciousness, and free will. Implications for physics and beyond. Despite these criticisms, the many worlds interpretation continues to inspire physicists and philosophers. It offers elegant solutions to some of quantum mechanics' most persistent paradoxes, such as the measurement problem and the collapse of the wave function. In physics, the many worlds interpretation has led to new ways of thinking about quantum phenomena. It's inspired research into quantum decoherence, which studies how quantum systems interact with their environments. Some physicists argue that decoherence can explain how the classical world we observe emerges from the quantum realm, without the need for wave function collapse. Beyond physics, the idea of parallel universes has deeply infiltrated popular culture. From Stranger Things to Rick and Morty, science fiction has embraced the concept, exploring the dizzying possibilities it presents. These stories not only entertain us, but also help us grapple with the profound implications of the many worlds interpretation. In quantum computing, the many worlds interpretation offers intriguing insights. The idea that quantum computers can perform calculations on multiple states simultaneously because they're actually operating across multiple universes is a mind-bending concept that's driving innovative research in the field. The future of the theory. As we move into the future, the many worlds interpretation continues to evolve. New variants and refinements are being proposed all the time. For example, David Deutsch's many interacting worlds theory suggests that parallel universes can have a subtle influence on each other, potentially opening up new avenues for experimental testing. Increasingly sophisticated experiments are being proposed to test aspects of the theory. While we still don't have conclusive evidence for or against the many worlds interpretation, each new experiment brings us closer to a deeper understanding of the fundamental nature of reality. Some researchers are exploring the possibility of quantum signatures that could provide indirect evidence for the existence of parallel universes. Others are investigating the role of quantum entanglement, wondering if entangled particles might be connected across different universes. As our technology advances, who knows what we might discover? Perhaps future experiments will provide compelling evidence for the many worlds interpretation. Or perhaps they'll lead us to entirely new theories we haven't even imagined yet. Conclusion. The many worlds interpretation challenges us to expand our understanding of what's possible. It invites us to consider that reality might be infinitely vaster and more complex than we ever imagined. It pushes the boundaries of our imagination and our science. Whether you believe in the existence of parallel universes or not, the very idea serves as a powerful reminder of the vastness and mystery of the cosmos. It encourages us to question, to explore, and to marvel at the infinite possibilities that the universe, or multiverse, might contain. In the end, whether the many worlds interpretation turns out to be true or not, it has already made a significant contribution to science and philosophy. It has pushed us to think in new ways, to question our assumptions, and to imagine possibilities beyond our everyday experience. As we continue our journey of scientific discovery, who knows what other revolutionary ideas we'll encounter? Perhaps, in some parallel universe, we already have all the answers. But in ours, the quest continues, and it's this quest that drives us forward, always toward the unknown. Thank you for joining us on this mind-bending exploration of parallel universes and the many worlds interpretation. I hope this episode has expanded your horizons and maybe even made you question the nature of reality itself. Remember, in science, it's not about what we believe, but what we can observe, test, and verify. The many worlds interpretation remains a hypothesis, albeit a fascinating one. As we move forward, we'll continue to probe the foundations of reality, always seeking a deeper understanding of our universe or universes. If you enjoyed this episode, don't forget to like, share, and subscribe to Sci Discovery Chronicles. Join us next time as we continue to explore the mysteries of the universe, one discovery at a time. Until then, keep questioning, keep exploring, and stay curious.